Good evening. Today we will be discussing about hydrogen production. So hydrogen, it is a clean fuel. It is having a high calorific value, that is 119.93 megajoule per kilogram. So it is higher than a very highly used type of fuels like the methane, which is having a calorific value of 50.02 megajoule per kilogram. Then gasoline, it is having 44.5 megajoule per kilogram, and ethanol, that is having 27.5 megajoule per kilogram, and ethanol, that is having 27 megajoule per kilogram. Means it is having all more than twice the calorific value than methane. Okay, even thrice more than gasoline and diesel. Means it is having a huge amount of energy. So it can be used in many type of applications like electricity generation. Okay, then petroleum refining, methanol production, fertilizers, and material processing. So further, the hydrogen, it can further be classified on the basis of the methods used for production of hydrogen. So hydrogen most commonly in the present scenario, it is being produced from steam methane reforming. Okay, from using methane. Okay, then with steam reacting with steam, and it is giving hydrogen and carbon dioxide. Means this process is not environmental friendly. It is a carbon intensive process. Similarly, the gasification of coal, that is also a method which is used for production of hydrogen. Because all of these methods, they are carbon intensive, they are not environmental friendly, they are emitting this carbon dioxide. Okay, and it is called as the hydrogen so produced, that is called as black or gray hydrogen. Black hydrogen when it is produced from the gasification of coal, and gray hydrogen it can be called by producing from the steam methane reforming. It is usually using natural gas as a fuel. Okay, because natural gas, that is having a good amount of methane. Okay, and then further we can use some of the techniques like carbon capture and storage and carbon capture and utilization, so as to uh, limit the emissions, the carbon emissions. Okay, so the hydrogen produced using CCU or CCS, carbon capture storage or carbon capture utilization, that is called as blue hydrogen. Okay, so what is carbon capture and storage technology? Basically, it is capturing and compressing carbon dioxide which is being produced. So not only in such a process of hydrogen production, whereas it can be used in other industrial applications, in power plants where the carbon emissions are taking place. So where the emissions are going on, from there, from the point of emission, the carbon dioxide that is being captured, and it is stored at some suitable location. And one more suitable location is the depleted region from where fossil fuels are already extracted. Okay, so there we can store this stored carbon. Okay, another technology of carbon capture and utilization, that also captures the carbon, but it is not storing it, it is utilizing it in other applications. Okay, so such applications like the recovery of oil or gas from the reservoir, and the production of fuels like methanol, ethanol, syngas. Okay, then production of chemicals like urea, polymer synthesis, pharmaceutical products, and manufacturing of stable mineral carbonates, and also in cleaning of saline water. Means the carbon dioxide which is being emitted, which is an ill effect on the environment, that can be captured, that can be utilized in other useful processes if proper technology is applied. Yes, but it has a drawback that these processes are costly. So the overall budget or the cost of the hydrogen, that may increase. Okay, and the last, the green hydrogen. The green hydrogen, how it is produced? It is produced using electrolysis of water. Means electricity that is being supplied to the water in an electrolyzer, and hydrogen and oxygen, they are emitted. So the hydrogen that which is being emitted is known as green hydrogen because it is environmental friendly, because oxygen is the only other product which is being emitted. So no harmful emissions, no effect on the environment. So it is known as green hydrogen. Okay, and electricity which is being used to dissociate the water and produce hydrogen, even that is generated using a renewable or clean energy source. Okay, so the most common renewable energy resource widely used are solar and wind. Using solar cells or using windmills, wind turbines, we are generating electricity. That electricity is not affecting the environment. That is environment friendly. And using that electricity, we are producing hydrogen by using an electrolyzer. So you are then electrolyzing the water. But one of the drawback with these type of systems, the renewable energy, that is that they are intermittent in nature, means the uh, solar availability, like we can say, it is not the same throughout. Sometimes the sun is available and solar radiation is available in good quantity. Sometimes it is available in less quantity in night, totally minimum. Okay, in the noon, afternoon, maximum availability. Okay, also season wise, the solar availability is changing. So it is having an intermittent nature. Same is the case with wind energy. The wind that is having a high velocity, it is having low velocity depending on the situation. Every time the velocity won't be the same. Okay, so they are intermittent. So what we can do here, so we can use the technique of electrolysis, we can produce hydrogen and then we can store it. And when there is a deficit, okay, then we can use the same hydrogen to again obtain or generate electricity. Okay, means it is working like a storage medium, something similar to that of a batteries. There also the surplus electricity that is being used to charge the battery, and then when the electricity is not available, then the battery is providing the electricity there. So similarly, the hydrogen storage system can be formed. So these are totally environmental friendly technique. Okay, so I think I should stop here.